Hi there, this is exercise 22C. We're going to look today at moments again, and in particular today we're going to look at what happens when you have moments with non-uniform rods. Now you might ask what non-uniform rods are. I suppose it's best to think of, well, last time we looked at rods and these were uniform rods. This is the example here. A uniform rod here is the seesaw itself. So you've got basically a plank of wood, not my best plank of wood. So you've got a plank of wood, and all the way along it, there's no reason to suspect that anywhere along this plank of wood, anything changes. It might, I suppose, depending on what's at each end, but for the moment, if you just think on a uniform rod, we basically assume that that's where the weight acts. This is called the center of mass, this point where it acts. And the weight acts down through the center of mass, and that weight then is right at the center of the uniform rod. Look, here might be an example where a rod might not be uniform. It's still the same seesaw, but sometimes you get like I don't know, you could for instance have a seat at one end which is working, which is, where the kid sits, and at the other end you can imagine, that seat has fallen off. Perhaps it's an old swing. Now you wouldn't now expect the center of mass to act here. We've got it might be a bit heavier now at this end, so you kind of expect the weight to act slightly further over, because now the center of mass has moved to here, simply because we've got one seat here but not at the other end. And of course, in addition to that, you've got the two kids sitting on the seats. But regardless of them, the rod itself now has got, I don't know, a non-symmetric weight distribution, which means its weight has moved slightly to the left. So there are situations which we describe to be non-uniform. That's when the mass within the rod itself is not evenly distributed. It might be because it's thicker at one end. It might be because it's made out of several different materials. I'm thinking perhaps of something like a fishing rod, where you've got the handle of the fishing rod. That's what the person who goes fishing holds. And then you've got a bar going through it. And that bar is actually made out of carbon fibre. It's meant to be very light. So you can see that the weight distribution isn't in the middle. The weight distribution is massively up this end, because potentially this handle is so much heavier than the rest of it. So that's what I mean by made of different materials. And in those situations, you would not expect to have the midpoint as being the center of mass. It would be maybe here. That's where the center of mass would act. And when you know where the center of mass acts, that's where the weight acts. So here's a question then. It says a non-uniform rod, so already we know we are talking about one of these funny ones, of length 6 and of mass 12, okay, and it hangs in equilibrium, usually from a ceiling, so let's just do that. It says it's supported by two light inextensible vertical strings, okay, so the strings come straight down, attached to its ends, and this says they are of equal length, so that basically means my rod goes straight across. Now I know that it says it's non-uniform, but I don't need to show that particularly. There's my rod. Well, the one thing I would suggest is we just show that the weight is not in the middle. So that's the weight. Anyway, let's just it says the tension in the first string is 88.2, so I'm going to call this the first string. T equals 88.2 newtons. It doesn't tell me this one here. That's an unknown tension. The distance on the center of mass, find the distance of the center of mass from the second string. Alright, so that means I'm going to call this x. That's the distance I want. What was its mass? Its mass was 12. That acts at this funny point, so its weight is 12 times. Now notice it's 12 kilograms, but that's not its weight. It's 12 times 9.8. And 12 times 9.8. A lot of people make silly mistakes with that. They just write 12. But it's actually 117.6 newtons. So that's its weight. we are asked to find this x. The simple way of doing it is to take moments. And because I don't know this tension here, it's relatively easy actually to find it. But because I don't know it, I'm going to take the moments from this end point. I can remember me saying to you, you can basically take it anywhere you like. You tend to try to use points where you don't know certain forces. So I'm going to call this the right hand side, and I'm going to take moments from the right hand side. Okay, the basic premise of this is anti-clockwise equals clockwise. So I reckon this, if I just think of that force, that would send it round. I reckon this is a clockwise force, whereas this one, the weight would pull it that way. It's an anti-clockwise force. So let's just do that. It's x times 117.6, the anti-clockwise force, equals the clockwise force. What was the length? It was 6 meters. So that's 6 meters away. So it's 6 times by the 88.2. So I can do 6 times 88.2. I'm going to immediately divide by the 117.6, move it over, or 4.5. So if I move that over there, I get x equals 4.5 meters. Was a distance? Yes, it was a distance. Answer 4.5 from the right hand end. So we've done it right. Notice the basic premise. We take moments, anti-clockwise equals clockwise, but on this question we couldn't assume the weight acting in the centre. In fact, they told us it was slightly off centre, and our job was to find out where exactly it was equal to. This question, they've drawn a picture for us. That definitely helps. A non-uniform rod, notice again, clues in the title, of mass 10. Immediately I'm looking at this, notice their notation 10g. That's the weight. This doesn't mean 10 grams because it says 10 kilograms. Should remember that. It means 10 times the 9.8, which is 98 newtons. So that is a force acting downwards. Oh, we've got two supports here. Does it tell me anything about it? It says, given that the reaction forces in the two supports are equal. Okay, so I don't know what they are, I don't think, but I can call them both R. So we've got an R force coming up here, and we've got another R force coming up there. Okay, distances. Well, I know it's 6 meters in length again, but this time these supports are slightly off the end, so that's 0.3. Oh, it tells me here, does it say that in the question as well? Yeah, the centre of mass is 2.5 meters from A. So 2.5 meters from A, this must be 2.2. Is this 3.2 then? Would that work? 3.2, that's 5.4, 5.76. Yeah, so I now know all four distances. I've got a decision to make. I can take moments anywhere I like. Again, it could be left hand end or right hand end up. I have no idea really. Let's first of all, before I do anything, I need to say something about forces, because we don't really know what the R is, but I'm going to need it. But fortunately we've got this rule that basically talks about the forces up must equal the forces down. So I've shown that with this arrow up equals arrow down scenario. And if forces up equals forces down, let's just write that down so it's very clear in your mind what is it I've tried to do. So forces up equals forces down. What forces go up? Well, there's only two. We've got an R up and an R up. So effectively it's like 2R going upwards. What's coming down? I've got this weight here. Oh, one thing I've not shown you yet actually. There is a mass here. I nearly missed this. There is a mass here of mass M, and this is actually what I'm trying to find. Now again, that's a mass. It's not its weight. So its weight is mass times 9.8, or if you like 9.8 M. Okay, so the forces down are the 98 Newton force down plus the 9.8 M Newton force down. I don't want 2R, I just want R, so I half everything and I say 49 plus 4.9 M. Okay, so I now have an expression for R, which I will need in a bit. And let's start this here. I'm going to take moment. The obvious thing to do is to pick one of these two. Last time I picked the right hand side, I'm going to do the same thing here. So right hand side, I think you can do either end, to be honest. So from the right hand side, what forces have we got? Now from here, because this force is acting at this point, we can ignore it. We don't have to worry about that one. But this one would make the bar go that way around. This is a clockwise force. Whereas this one and this one, these are both anti-clockwise forces. So when I do clockwise, or rather anti-clockwise equals clockwise, I've got, let's just say, I've got the 98 times by the 3.2. So let's do this. 98 newtons times by 3.2 meters. Plus this one, what's this? This is a force of 9.8 m times by, it says it's 1 meter away. And that is equal to the clockwise force. And the clockwise force, I reckon, is 5.4 meters away times by the r. What was the r again? It was all this. All right. So I'm just going to tie that up. I need to do 9.8 times 3.2. That's 31.36. No, I did. It's 98 times the 3.2. That would be a bad mistake. It's 313.6 plus 9.8 m. And this right hand side, I'm going to write as 5.4, and it's times by r, so it's all this lot. So times by the 49 plus 4.9 m. That's a bracket. So I need to multiply out this right hand side. 5.4 times 49 is 264.6. Because they're the same numbers, and multiply that out, I'll get 26.46 m. And that's equal to 313.6 plus 9.8 m. So I need to get all my m's on one side. I'll move the m's that way, I think. I'll move the numbers this way. 313.6 minus the 264.6. I get 49 on the left hand side. And on the right hand side I get 26.46 minus 9.8. 16.66 m. So presumably the m is equal to the 49 shared by the 16.66. 49 divided by 16.66. Right, it's 50 over 17, or 2.94. In mechanics you tend to just write the answers using decimals to three significant figures. 2.94. See if that's right. 2.94. Should have said kilograms. Naughty. Oh, is that right? Yeah. 2.94 kilograms. We both got it wrong. So that's how you do it. So I want you to have a go at some of these. There's only the two questions on this PowerPoint. So have a look at this. This is exercise 22C. You should find you get a variety of questions. Any problems, let us know and we'll sort them out with you. Good luck.